Hello, my name is Sojeong. In this research, we investigated the potential and challenges of do-it-yourself smart homes with a machine learning intensive camera sensor. Let me summarize the contents of our study. We conducted a 7-day field diary study with 12 families who were given a do-it-yourself smart home kit. As a result, we assessed the 5 characteristics of the camera sensor, as well as the potential and challenges of utilizing the camera sensor in the do-it-yourself smart home, and discussed the opportunities to address existing do-it-yourself smart home issues. In do-it-yourself smart homes, users can actively connect various sensors and actuators to customize features that solve their complex problems to meet their individual needs. IoT sensors, which have been commonly used in smart homes, can only provide information at an indirect level, which means only limited activities can be deduced. For example, when using a door open sensor, one cannot definitively answer the question, "Did the children come home from school?" Based on the limitations of these existing IoT sensors, new types of sensors have emerged to recognize more specific and concrete activities. And the machine learning intensive camera sensor is a representative example. Camera sensors enable explicit interaction, however, the unfamiliarity and increasing complexity of new types of sensors make them still difficult to use. In this study, in response to these sensor changes, we explored the potential and challenges of do-it-yourself smart homes with a camera sensor that have arisen compared to commonly used IoT sensors. To achieve this goal, we conducted a comparative study between commonly used IoT sensors and a camera sensor. And we gave them a do-it-yourself smart home kit. With this, we encouraged participants to build simulation prototypes to express their intended functions. We referred to several studies in smart homes and listed the types of commonly used IoT sensors and actuators. For the camera sensor, we used a simple wireless camera that can also be linked to Google's Teachable Machine. Teachable Machine is a web-based graphical user interface tool that uses a camera to help users create customized machine learning image classification models without professional technical knowledge. We recruited 12 families based on gender, age, family type, and coding knowledge. Additionally, we asked each household to select a representative active participant in this study. Our study consists of 3 sessions. After performing ice-breaking activities on the first day, the activities of deriving smart home ideas on one day and implementing them on the next day were repeated thrice. We explained how to connect sensors and actuators and conducted a teachable machine tutorial to teach beginners to use a camera sensor. Because the building functions had to be developed using Scratch, we also briefly described the core coding blocks of Scratch programming. In session 2, we developed an activity in which participants looked back at their homes and routines to effectively discover desirable smart home features. In session 3, participants implemented the ideas using Scratch they had derived in session 2. After completing the 3 sessions, we interviewed participants with the aim of comparing the experience of using a camera sensor with that of using commonly used IoT sensors. After extracting key quotes from the interviews, we qualitatively analyzed the interview data through thematic analysis. Subsequently, we analyzed the sensor utilization process into 5 stages and derived the characteristics of the camera sensor. Then, we described the findings regarding the new user experiences, as well as the potential and challenges caused by the new characteristics of the camera sensor. The first finding is, when participants used the commonly used IoT sensors and the camera sensor, they showed differences in the order between selecting a sensor and determining the sensing situation. As the functionalities of commonly used IoT sensors are already defined, they had to first consider the functionalities of the sensor and then reconstruct the possible situations to be sensed. In contrast, when using a camera sensor, which has no predefined sensing functionality, participants were able to match the functionality of the sensor to the situations they really wanted to sense, without any restrictions. For example, a camera sensor can detect the movements of someone doing push-ups or identify which child has arrived home. With the camera sensor, participants did not have to think about the regularity of implementing smart home features when using the camera sensor. But they sometimes struggled with it because they did not have a clear idea of the camera sensor's ability. Second, when using commonly used IoT sensors, participants adopted a gradual top-down approach to narrowing down the sensor's specific role by adding time or space as a constraint factor. Whereas for the camera sensor, they utilized a gradual bottom-up approach, in which the sensor's role was determined through teaching, based on demonstration. For example, users could group various activities performed on a desk into distinct categories, and label them as desk activities. With the camera sensor, participants were free to modify and expand the features they had already implemented. But they said that they needed further support in teaching the appropriate roles of the camera sensor. After specifying the sensor's precise role, participants had to choose an appropriate location for the sensor. Participants had to come up with sensor location ideas to improve accuracy while using commonly used IoT sensors. When utilizing camera sensors, they had to place sensors such that multiple features could be implemented by one camera sensor. The camera sensor naturally led participants to consider the association between features. But they said intuitive recognition of what features are enabled in one camera sensor was very difficult. Fourth, they established rules based on numerical data while using commonly used IoT sensors, while they established rules based on intuitive image data when using the camera sensor. With the camera sensor, the implementation process and results when using the camera sensor were much more readable than those when using commonly used IoT sensors. But the property of visual element-based sensing raised users' privacy concerns. Finally, when using commonly used IoT sensors, participants modified the rule by changing environmental factors and observing sensor values, which was an effect-driven approach. If an error occurred when using the camera sensor, the participants modified it by trying to review the previous image data used for teaching, which was a cause-driven approach. Rather than self-experimentation, participants likened the debugging process using camera sensors to a spot the difference puzzle. But participants stated that it was important to improve the efficiency of the data screening process. In the discussion section, we addressed the DIY smart home issues as a result of the new user experience and the characteristics of the camera sensor. Discussion point 1 explores new opportunities for camera sensors, concentrating on concerns in the present do-it-yourself smart home. First, the use of camera sensors is facilitating the implementation of individual-oriented smart home features. Second, an intuitive implementation is enabling family involvement in the process. Lastly, these features can be conveniently adjustable to meet their evolving needs. Discussion point 2 addresses the privacy issues connected with camera sensors, based on our findings of the 5 characteristics of camera sensors. Incorporating a DIY approach may be necessary to address potential privacy concerns associated with certain camera sensor characteristics that can exacerbate privacy issues. This approach empowers users to determine what the sensor observes, how it interprets the situation, and what outputs should be given. These are the limitations of our study. The corresponding representatives may not have considered the diverse demands of other family members. Also, privacy issues between individual family members must be considered. Lastly, this study focused on the motivation and implementation processes to investigate the participants' experiences with a camera sensor. In this research, participants freely built smart home features using a kit including a camera sensor, and conducted a 7-day diary study. We investigated the new user experiences with the advent of machine learning-intensive camera sensors, and derived the findings with a focus on the new, potential, and challenges. By summarizing the findings of this study, we were able to generate discussions on the opportunities associated with camera sensors for existing do-it-yourself smart home issues. We believe that these discussions may lead to the design of more successful and user-centered DIY smart homes based on machine learning-intensive camera sensors. Thank you.